Everyone, today we are going to review what you did in the 8.5 discovery activity in Edulastic and go over a few more examples. So what you learned is how to factor a quadratic trinomial just with the leading coefficient of 1, because if it's not 1, then it's a little more complicated. And then we want to do that because we can only find the solutions of a quadratic trinomial if it's factored by using the zero product property. So if we want to solve an equation like this, or I'm going to skip ahead to our examples. If we want to solve an equation like this, we need to get it into factored form. So that's what we're going to do. So we're going to go over a few examples of different cases. So the first type is when the b and the c term are positive. So what I mean by that is your quadratic trinomial is in the form ax squared plus bx plus c, where c is the constant, ax squared is the quadratic term, bx is the linear term, a, b, and c are coefficients, and for us, this a term is just going to be 1. So you're not going to see a number in front of the x squared term. It's just going to be 1. And so they say, okay, well, what if the b and c, what if it's all positive? Okay, so what if the b term and the c term are positive? So what we need to ask ourselves when we're factoring, what you learned from the investigation is what two numbers multiply to get 18, but add or subtract to get 11. So what two numbers multiply to 18, but combine to be 11. So factors of 18 are 18 and 1, 9 and 2, and 6 and 3. So which of these combinations would also add or subtract to get 11? And that would be 9 and 2. And then they're both going to be plus in our factored form because bx, b, and c are positive. Okay, so I'm going to set up my factors. The first terms are both going to be x because when we do first, x times x is always x squared. And then the other two terms are going to be plus 2 and plus 9. Now, it does not matter the order that you put these in, okay? Putting plus 9 or plus 2 is fine as long as you have the correct sign. And if we wanted to solve this, and if it was set equal to 0, our solutions would be x equals negative 2 and x equals negative 9. All right, but if it's just saying to factor, then you're just going to put it into this form. So that's what it looks like if it's factored. And then if we FOILed it, we should get back to our original answer. All right, so we'll do a couple more. Actually, I think B was down here. All right, so remember, what two numbers multiply to get to the last one, but add to get to the middle one? Well, the only factors of 2 are 2 and 1. And then 2 plus 1 gives us 3. So those are going to work. So we'll do x plus 1 times x plus 2. I tend to put the smaller number first. But once again, it doesn't matter. You could have x plus 2 and x plus 1. All right, part C, what two numbers multiply to get 10, but add to get 7? Factors of 10 are 1 and 10 and 2 and 5. So 2 and 5 are going to be the correct numbers to use in our factoring. So we'll do a plus 2 times a plus 5. Sorry, that's an a. All right. For this one, all right, so 12. So there are a lot of factors of 12. There's 1 and 12, 2 and 6, and 3 and 4. So which one of those would combine to get 8? 2 and 6. So we'll do x plus 2 times x plus 6. All right. And notice I'm kind of skipping these ones just because they're similar and I want the video to be shorter. So how about when the middle term is negative and c is positive? So let's take a look at what the factors of 8 are. They're 1 and 8 and 2 and 4. So which one of these combine to be 6? Negative 6. Well, it would be 2 and 4. 1 and 8 can't make us 6, but 2 and 4 can. But what we're going to have is not just 2 and 4, but negative 2 and negative 4. So when the last term is positive, that means it's both going to be plus or they're both going to be negative. It can't be one plus and one negative because that would give us a negative answer for the multiplying term. So if they're both negative, then negative times negative is a positive, but they also will add to be -6. Okay, so that means in the factoring, we're going to have n minus 2 times n minus 4. And if we set this equal to 0 and solved, our solutions would be n equals 2 and n equals 4. All right, let's do this one down here. So the only factors of 3 are 3 and 1, but since the middle term is negative, that means, and the last term is positive, that means they're both going to be negative. So we would have x minus 3 times x minus 1. Once again, it doesn't matter the order that you put them in. How about this one? So 12, we could do 1 and 12, 2 and 6, or 3 and 4. Well, 2 and 6 would give us negative. I'm so sorry, guys. So make sure you published your February attendance. Both negatives. And please spread the word to those teachers coming in. Right. So t minus 2 times t minus 6. Attendance is published. We're getting calls about a couple classes. Thank you. All right. So for this one, let's see. This one is tricky because 1 and 6 and 2 and 3 both could combine to be -5, but you need to remember that if this is plus, they will both have to be negative. So if these are both negative, that would give us -7. If these are both negative, that would give us -5. So these two are going to be the factors. So we'll have n minus 2 times n minus 3. All right, let's look at the last case. If b is positive, or it could be negative, and the last term is negative. So if the last term is negative, then it's going to be 1 plus and 1 minus. So this is the trickiest one because you're going to have to figure out which one will be plus and which number will be negative in order to give us a positive 2. So factors of 15 are 1 and 15. That's obviously not going to work. No, not 2, sorry, 3 and 5. And that's it. So 3 and 5 are going to be our solutions. But if we want a positive 2 in the middle, we'll have to have the larger factor be positive. So it's going to be -3 and +5 to give us positive 2. So in my factors, I would write y minus 3 times y plus 5. And if I set this equal to 0 to solve, I would get y equals 3, y equals -5. But this would be the factoring part. All right, for this one, if this is 30, we've got 1 and 30, okay, and then we're trying to figure out how to combine it to be positive 1, so that's not going to work. How about 2 and 15? Nope. 3 and 10? Nope. And my last one would be 5 and 6. 5 and 6, I think, will be the winner. But which one will be plus and which one will be minus? Well, if we're trying to get plus here, we want our larger factor to be plus. So it's going to be -5 plus 6 will give us positive 1. If this was m squared minus m minus 30, then we would want the 6 to be negative because positive 5 minus 6 would give us -1 in the middle. All right, so here we'll have m minus 5 times m plus 6. And I think we will just skip to these last couple examples here. So solving. Okay, so if it's like this and you want to solve, there's an equal sign. You have to have equals 0 to solve, but this equals 18. So what we're going to do is subtract the 18 over. So we'll have x squared plus 3x minus 18 equals 0. All right, so now we're going to have to factor. So first step is to get it equal to 0. Second step is to factor, so write your two factors. And then the last step would be to set each factor equal to 0 and solve. So when we factor, put x here, x there, and then we ask ourselves what factors of 18 will add to be 3? Well, let's think. We've got 1 and 18, 2 and 9, and 3 and 6. So the 3 and 6 are going to be what will add to be 3. Since it's -18, that means one of these will be plus and one will be minus. They both can't be negative because that would give us a positive 18. But since you want your middle term to be positive, that means you're going to make the larger factor be positive. So it's going to be -3 plus 6 will give us positive 3 in the middle. So you'll do x minus 3 times x plus 6. And then if we set each of these equal to 0 and solve, we would get x equals 3 and x equals negative 6. All right, and then we'll do one more of these examples. Oh, I think it's down here. All right, so here, just like the other one, I'm going to subtract the 24 over to get one side equal to 0. So factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So which one of these factors would combine to be negative 2? The 4 and the 6. Now, since you want your 2 to be negative, you're going to want the larger factor to be negative, so that would be positive 4 and negative 6. So we'll have x plus 4 times x minus 6 equals 0, and that would give us x equals negative 4 and x equals 6 as solutions. Now, when you are solving these equations in Edulastic, it's not going to just ask you for the solutions, it's also going to ask you for the factored form, just because I want to make sure that you know how to do this and that you're not just trying to plug it in your calculator to figure it out or using guess and check. I want to make sure that you know how to factor like this. All right, so we're going to do one more example for a word problem. So you're designing a flag for the school football team with the dimensions shown in the diagram. The shaded region will show, so this part here, will show the team name. The flag requires 117 square inches of fabric. Write an equation for the area of the flag and find the width of the flag. All right, so area is length times width. Our length is going to be 2 plus w plus 2, which the whole thing would be w plus 4. So, and then the width would be w. So area length times width, or width times length, would be w times w plus 4. And I usually write the monomial first and then the binomial. And then that's equal to the area, which is 117. And I know to set it equal to 117 for this example because it says to write an equation. So we need to have it equal to something. So in order to solve, we'll need to get it all equal to 0. So I'm going to subtract, not just subtract the 117 over, but I'm also going to distribute the w so that I can refactor it when I subtract the 17 over. So distribute the w squared plus 4w, subtract the 117 over, right? And then I'll set up my factors, because you can only solve a quadratic equation like this if it's factored. So I have w in the first spot, and then factors of 117 that add to 4. If you play around on your calculator for a little bit and try to figure out what are factors of 117, you would get 9 and 13. And 9 and 13 would add to 4. But the question is, which one will be the negative one? Well, if you want it to be positive 4, you want the smaller number to be negative and the bigger number to be positive. So have w minus 9 and w plus 13. Right, so we factored it, and now we want to find the width of the flag, which means you would set each factor equal to 0 and solve for w. So this solution would give us w equals 9. This solution would give us w equals negative 13. Since you can't have a negative width, 9 is going to be your answer. So 9 inches. All right, that is the end of this lesson. Tomorrow you will get even more practice with this plus word problems. Hope you guys have a great day.